Pre-calculus students, welcome to section 10.6 on parametric equations. So we are studying parametric equations because it is, again, now that we're getting further in your math journey, we are able to show you some things that are actually more real world like, but maybe more complicated. But now you can handle it. I may have alluded to in class before that when we write equations, XY equations, that we say X is the independent variable and Y is the dependent variable. And that is true in that case. And by the way, equations now that are written with X's and Y's are called rectangular equations because we can record their solutions on a rectangular plane. Before we just called them equations. But now that we're going to be working with parametric equations and polar equations, we now have to have a name for XY equations. And so parametric equations is where T, or time, is the independent variable in both X and Y depend on that time. And again, that's really the way the world works. When we've been drawing conic sections, and even in the past when we've drawn lines, we've kind of referred to them as objects, right? In our 10.2 to 10.4 notes, right? Here is an object, it's an ellipse, right? Here's a hyperbola, here's a parabola. But the truth is that when we draw these conic sections, they form over time, right? And just like when you have a projectile, when you throw it over time, there is a horizontal and a vertical position that projectile has, and it depends on time, right? When we have orbits for ellipses, again, its position, its XY position depends on time. And so now we're going to be working with parametric equations, which have a pair of equations, one being X equals and one being Y equals. And your calculator actually is very good at parametric equations. If you notice on your calculator, on your X button, there's a T, and that is for parametric equations. And your calculator is able to graph parametric equations too. So let's get started with that. I hope you don't hear that. My neighbor is vacuuming kind of loudly above me. So looks like we'll do that with a little vacuuming going on. So I'm going to share my screen, and you have pulled out your chapter 6, your 10.6 notes, which we have here. Okay, so let's start filling in these notes. So what are parametric equations and why do we study them? They have I'm going to turn this a little bit. They have a parameter. I haven't written in a while, so hopefully I do a good job. They have a parameter of T, meaning time. Equals time. And X and Y are dependent on time. Okay, so we will have a pair of equations for parametric equations. Pair of equations. One being X equals and one being Y equals, and with T is the input. Okay, again, we study them because many of our conic sections and equations, many of our equations or graphs are formed over time. We do study in Calculus 2 parametric equations and polar, and this is pre-calculus. And so it doesn't just relate to Calculus 1, but to Calculus 2 also. Sorry, needed a little sip of water there. So how do I graph parametric equations on my own? This is number 2. So if you take a look, we have 2 parametric equations. X equals t minus 4 and y equals, that's a negative 2t plus 5. And we have a chart of different times and spaces for X values and for Y values. And so what we're going to do is at a time of 0, let's do the first row for the X equation. We're going to put a 0 in for the T, and of course we get a negative 4. It doesn't seem to want to do a negative. That's a negative 4. Let me try again. Nope, doesn't want to do it. Okay, and when we put in a 1, we get a negative 3. Okay, doesn't really want to do that real well for me. But so those little dots are negatives. Let me try on the next one. When we put in a 2, we have a negative 2. There, that's a little better, right? When we put in a 3, we have a negative 1. When we put in a 4, we have a 0. When we put in a 5, we have a 1. And when we put in a 6, we have a 2. Let's do our y equation, right? So we're going to go back to our t's and put in 0 for our t, and that will give us a 5. When we put in a 1, we will get a 3. Let me try that again. There we go. When we put in a 2, we'll get a 1. When we put in a 3, we'll get a negative 1. When we put in 4, we'll have negative 3. Oh boy, well, gonna have to redo that. Sorry about that. You can skip over that, and it just wasn't doing well for me, but we can do this kind of quickly. Let me give myself some more room here. Let's go back to the X equation. When I put in a 0, that was a negative 4. A 1 is a negative 3, right? Negative 2. Negative 1, 0, 1, and 2. So sorry about that. Again, let's put in t's, our t's into our y equation. That would be a 3. Sorry, when I put in a 0, sorry, negative 2 times 0 plus 5 is 5. Sorry, that deleting kind of threw me off. There we go. When I put in a 1, I get a 3. When I put in a 2, I get a 1. When I put in a 3, I get a negative 1. When I put in a 4, a negative 3. When I put in a 5, that's a negative 5. And when I put in a 6, that's a negative 12. Oh, negative 7. Sorry, class. There we go. I'm going to keep going. I could redo this, but I gave such a lovely speech at the beginning, don't you think? So, hey, there's our chart. Okay, so let's take a look. So when it says, how do I graph parametric equations on my own? Let me just check my data really quick. So my axis should have been going up by 1. They are. My y should have been going down by 2. They are. In the end, we're okay. So the first thing we do is we are going to graph the first point, negative 4, and 5, right? That's right there. Okay, then we're going to graph negative 3 and 3. So negative 3 and 3. There we go. And then negative 2 and 1. There we go. And now I'm going to start to connect these because I just want to show, once you do 1 or 2 points, you are going to put arrows to show how this looks like it's going to be a line is being formed. So you will have arrows showing direction, right? Then we have a negative 1, negative 1, right? And a 0, negative 3. Let's connect those again and put an arrow. 1, negative 5, and 2, negative 7. There we go. There we go. Connect. There we go. Not that pretty, doing my best with my writing utensil, but it's supposed to be a line, right? And And so it being formed over time. So with parametric, we put the arrows on it. Now let's go to x equals 3 cosine of theta and y equals 5 sine of theta. Now, by the way, even though there's theta, when you do parametric equations in your calculator, they really are still a t. So these are really still t's, but I wanted it to match what you'll see in your book. Okay, so let's go through and put in our thetas or our t's and get our x's. So when you put in a 0 for theta or t here, cosine of 0 is 1 and then times 3. There we go. When you put in pi over 2, cosine is 0. When you put in pi, cosine is a -1. When you put in 3 pi over 2, cosine is 0, and a 2 pi, and we're back to 3. Okay, let's go to our y equation. When we put in a 0 for 5 sine of theta, we get a 0. When we put in pi over 2, sine is 1, so we have 5. When we put in pi, we get 0, right? 3 pi over 2 is a -1, so we have a -5. And when we put in 2 pi, we're back to 0. So I just wanted to show you then, you're going to have to trust me a little bit on this one, because it would have been nicer for us to have other angle measures in between 0, pi over 2, pi, 3 pi over 2, and 2 pi. That would have been nice to have, but it also would have been more confusing for graphing for you. So if you would believe me as I draw this, that this is actually going to form an ellipse, and you'll see later that that is true. So we're going to graph the point 3, 0. There we go. And now the point 0.05, which is right there. Okay, and I'm going to show the direction. And just so you know, I know you don't know this yet, but it's not a line, it is a curve. And here's our direction. Let's put in -3, 0, right? And so we are curving down, and I'll put an arrow for our direction, right? Then we have 0, -5. Here we go. And then we're back to 3, 0. So, and we have an ellipse. There we go. And that's our parametric equation. Okay, on number 3, how do I graph parametric equations on my graphing calculator? Okay, so let's go here. So here are the basics, right? The basics is when to use parametric equations, your mode has to be in parametric. So that is right next to the function. And let me see, and we'll show you too. It is the 4th line down. You have to be in parametric. When you do your window, you would first do a zoom 6. Window would be a zoom 6, which is a standard window. But after that, you really want to do a 5, which is square, which gives it it's more realistic shape, but often your calculator won't do the 5 before the 6. So you have to do a zoom 6, then a zoom 5, okay? On your window, we're gonna check, there's actually a thing called a step, and you want it pretty close to a 0.1. If it's a lot smaller than 0.1, perhaps 0.01, when you're graphing parametric equations, it will form the graph very, very slowly. If you have a step a lot greater than 0.1, it's going to form your graph so fast that you can't really tell the direction and tell what happened. And again, let's remember that even if in your book they give you a theta as an input, it really is going to be a t. So now what we're going to do is we're going to graph the 2 sets of parametric equations from number 2 above, right? So what I'm going to do is I am going to go back to stop share, and I'm going to go back to my graphing calculator. Okay, so you are currently looking at your calculator, right? I am too. There we are. To see if I can get a good angle. There we are. So I made sure that I am in parametric mode. I'm also going to be, I believe, in radian mode for the second parametric equation on number 2. So just make sure you're in radian mode also. Okay, And so now when you go to, you may want to check and make sure your stat plot is off too. Okay. Now, when you go to your y equals, if you notice, right, it actually has pairs of equations. It has an x1 and a y1, an x2 and a y2, and it has a little t next to it. So it actually gives you little pairs. Okay. So on your worksheet, let's go to 2a, what we just drew ourselves. And our first x equation, if you look, is t minus 4. So how do you get the t? You just hit the x button, right? Your x button has the t on it right there. And now when you hit the x button, it gives you the t, right? So you have t minus 4. Excellent. Okay. Now, our y equation was a negative 2t plus 5. A negative 2t plus 5. There we go. Okay. I'm going to check my window. Notice you're like, what is the step? Now take a look at your window. You have a t minimum of 0. That is the best way to go because it's time, right? You have a t max of 10. Look, notice your t step is 0.05. I am going to change, that's the third line down, my t step to 0.1. Okay, there we go. And you know what? I think if I hit a zoom 6, it's going to do what I want anyway. Let's do zoom 6, right? So I'm going to hit zoom and I'm going to hit 6 so you can see it. There you go. Look, it forms the same line we did, and you could actually see it being formed. Now let's go to the window. There we go. It made its own step of 0.13, and that is perfectly acceptable. So kind of cool that on the calculator, you can do that. Let's go to 2B on your worksheet. Clear out your x1 and your y1, your pair of equations. They're parametric. And for our x equation, we're going to put in 3 cosine of t. So you're going to hit the x button, 3 cosine of t. Again, make sure you're in radian mode. And on your first y1, you are going to put 5 sine of t. There we go. So you put in your equations. There you go. Let's do a zoom 6. And now we'll see if you believe me that we really do have an ellipse. Look at that. Now, when you graph it, see how it looks more like a circle? That's because your axes aren't square. So let's do a zoom 5. Zoom 5. That makes the intervals on the XY axis the same. There you go. It is, in fact, an ellipse. So now you believe me. Okay. All right. Now, let's go down to number 4, right? So I'm going to go back to the worksheet. There we go. And number 4, how do I write parametric equations in rectangular form? So let's take a look. Here are the basics. There's actually 2 things. We're going to make a little squiggly here because there's 2 ways. The basics are get t alone, in x equation, get t alone in the x equation and substitute in the y equation. Okay. If you have thetas and sines and cosines, right, then we're going to be over here on the right. What we're going to use is we're going to use the Pythagorean identity. Thought you were done with it, right? That cosine squared plus sine squared equals 1. So it turns out, how about that, that everything in math is related, even in parametric equations, okay? And because if we're going to write parametric equations to rectangular form, right, then we somehow have to get our cosines and sines into one equation. And we are going to relate that by cosine squared plus sine squared equals 1. Okay, so what does this mean on number 4? What are we going to do here? So This means on number 4, take a look. Here's our set of parametric equations that we drew ourselves and that we also put in the calculator. How do we get this to just be a regular XY equation? Okay, the first thing you do is get the Y alone in the X equation. So take a look at your X equation right here. And I meant get the T alone. And let's get the T alone by adding a 4 to both sides, right? So my X plus 4 equals T. Okay, now what I'm going to do is, right, because we're trying to write a rectangular equation where Y equals something. So we're going to take our expression for T and put it right in for T in the Y equation, right? So let's start writing our Y equals equation. Y equals -2. There you go. Where the T is, I'm going to substitute in X plus 4. And then we have plus 5. So notice your T's are gone, right? You have an XY equation. Y equals -2X. Notice this is a -8, sorry, plus 5. -8 plus 5 is a -3. And there you go. Now take a look. When you go back up to your equation, 2x minus 3, take a look. That really is a line that has a y-intercept of -3 and a slope of -2, right? Okay, what are we going to do to turn this set of parametric equations into just having x's and y's? Here's what we're going to do. We are going to use cosine squared plus sine squared equals 1. Okay, so let's take a look here, right? So the first thing I need to do is I need cosine alone and I need sine alone. So I'm going to divide both sides by 3 for my x equation. That's a 3 there. And I'm going to divide both sides by 5. There we go, for my sine equation. So here's what I have right now. I have x over 3 equals cosine. And I also have y over 5 equals sine. But I need cosine and sine to be squared, so I'm going to square both sides of both equations. There we go. Okay, now here's what I know. I know that cosine squared plus sine squared equals 1. Well, take a look what cosine squared is. It's x squared over 9, right? So right here where you see cosine squared, I'm going to substitute x squared over 9. Plus, right here where you see sine squared, I'm going to replace that with y squared over 25 equals 1. Well, take a look at this. There, we have a rectangular equation just in terms of x and y. And take a look, you know from doing conic sections, this is an ellipse. You know your a squared is 25 and your b squared is 9. You see your a squared is underneath the y, so this is a vertical ellipse. So it goes up, it has a center of 0, 0. It goes vertically up 5 and down 5 from the center and horizontally right 3 and left 3. And let's go back and take a look. Take a look. That really is the ellipse that we see here. All right. So if we should be able to convert from parametric to rectangular, we should be able to convert from a rectangular where you have an x and a y to parametric, right? So we're going to do that in 2 ways. Here's our A. So you know if we're going to write parametric, that we have to have a pair of equations. Well, take a look on A. They told us t equals x. So hey, there's our first x equation, right? X equals t. There we go. then all we have to do is where you see, here's your y equation, y equals x squared plus 3, right? So y equals, right, here's our second part of our pair of equations. My x right there is a t squared plus 3, and there you go. There is the set of parametric equations for the rectangular equation they gave us. Let's try B. What if they tell us x is something else? B. What if they tell us x is 2, t is 2 minus x? Let's work that out over here. Let's get that x alone. That would mean that t minus 2 is equal to a negative x, and when I multiply everything by a negative, I get x equals 2 minus t. There we go. So there's my x equals equation. All you have to do is turn around the t expression they gave you. Now for my y equation, I'm going to go back to my y equals x squared plus 3, y equals, and where there's an x, I'm going to put 2 minus t, because that's what it says above it is. There we go. Now, this y equation is perfectly correct, but most likely they're going to FOIL it out and gather their like terms. So y equals 4. I'm just FOILing out 2 minus t. That would be minus 4t plus t squared plus 3. And my final y equation would be, I'm just going to put it in standard form. That would be t squared minus 4t plus 7. There we go. And there's our set of parametric equations. Okay. Now, last, graph both sets of parametric equations on the graphing calculator to verify. I'm sure that you can do that. Okay. So let's go on. Let's look at number 6. A useful application of parametric equations is projectiles in motion because of the independent horizontal and vertical components over time, right? So here's where we are now. So when you have a projectile in flight, you can tell its horizontal position if you take the time, multiply it by the initial velocity and cosine of the angle from the horizontal. You can tell its vertical position by taking the time, multiplying by the initial velocity, sine of the angle from the horizontal at which it was projected, minus 16t squared, right? That is due to gravity, right? Acceleration due to gravity. So what we're going to have here is a ball A. It's going to have an initial velocity of 30 feet per second and an angle of 25 degrees. So we're going to need to be in degree mode. Ball B has a higher initial velocity of 40 feet per second, but its angle is 80 degrees, much higher, right? Nearly vertical. So what we're going to do is we're going to graph both of these balls on our calculator on an X1, Y1, and then on an X2, Y2. And we are going to watch them in flight and see if we can answer the questions that they're asking for. Notice that because this is kind of new to you, that I put what the window should look like. Okay, so first, let's just write the equations below that we're going to put into the calculator. Okay, so for ball A, and then we'll go to our calculator screen. For ball A, we will have X equals, let's see, T times an initial velocity of 30 times cosine of 25. Okay, for Y, we will have T times 30 times sine of 25 degrees minus 16t squared. That will be our X1 and our Y1. For ball B, we will have on an X2, T times 40 times cosine of 80. And And on a y2, we will have t times 40 times sine of 80 minus 16t squared. Okay, and I was asking you to make some predictions here before we put this into the calculator. Which ball do you think will have the shortest time in flight, A or B? What do you think? So make a prediction. Which ball will be in the air the longest? Which ball will have the longest range and go further horizontally or vertically? That would be A or B. So you pick which ball do you think is going to go furthest? And which ball has the highest vertical height, right? So you could answer what you think is going to happen there. Okay, so let's get this into the calculator. Okay, so I am clearing out my X1 and Y1 right now. And on an X1, I'm typing what I see in the screen, right? So that's T times 30 times cosine of 25. There we go. Then for a Y1, I'm going to have T times 30 times sine of 25, right, minus 16t squared. I'm going to keep going. I'm now to my X2. I'm going to put in T times 40 times cosine of 80. And then on my Y2, I'm going to put T times 40 times sine of 80 minus 16t squared. So it looks like quite a bit in your calculator that we have here. Okay, now, so lots going on there, right? I'm going to set my window now, just like you see with stars, right? That I had between the stars here. So go to your window and you just go straight down. Your time is 0. Time minimum, 0. Time max, 10. Your step is 0.05. I'm now down to X minimum. There you go. X minimum would be 0. X max, 25. And my scale is 1. I'm now down to Y minimum. So I'm going down the list on my calculator on the window and I'm reading across my sheet right here. There we go. So my Y minimum is 0. My Y max is 30 and my scale is 1. So now I'm going to go to mode, right? And on my mode, it says to be in degrees. And if you go down, this is pretty cool. 1, 2, 3, 4, 5, 6 to the 6th row, it's always on sequential, but you're going to move to the right on simultaneous. Okay, so let's do this. All right, so I'm going to start sharing my screen. Right, here we are. So again, here is my mode, right? I'm in degree mode. I'm in parametric. And if you look further down, I'm on simultaneous. Okay, when you go to your Y equals, I have in my equations, hopefully I put them in correctly. I hope so. When I go to my window, I read across the row on the worksheet and went straight down. So here's what we're going to do. Okay, we are going to hit zoom. We're going to just, no, we're not. We're going to hit graph because we made our window ourselves. Okay, we're going to hit graph. Ready? This is kind of cool. You hit graph. Ooh, look at that. So notice that the balls like go at the same time simultaneously. So what you could see is ball A, of course, was the lower ball. That had the shortest time in flight, but if you notice, it went the longest horizontal distance. Obviously, ball B had the longest time in flight and had the highest vertical distance. So I just think kind of cool that you can actually show projectiles here. So thanks for hanging out with me today on section 10.6, and we'll talk about it more in class and have a great day.